I'm Arnold T. Saladaga, and I will show you an Excel program about shear in beams. So here in this program, makikita natin na may dalawang way of solving, which is ang NSCP Code 2001 and NSCP Code 2010 or 2015. Now, makikita natin dito sa may top left, input values. So dito natin nilalagay ang lahat ng mga values or mga given. And then, sa baba, may makikita tayong calculations and the condition for SMAX. And then, dito sa loob, paano makuha yung mga values. So, dito may reactions, may VU or ultimate shear, may shear in VC, shear in critical section, and your VS. And then, your phi in 2001, which is given 0.85, and in the 2010, 0.75. And so we will have, or meron tayong VC over 2 VC for VC, your area of the cutted section of your stirrup, and then the stirrup spacing, which is S. At saka dito sa orange na color, dito mo ilalagay yung iyong assumed value, or let's say yung gusto mong value gamitin na sa iyong design. So next, we have adequacy, checking for adequacy, check for the SMAX, and the location for first stirrup. So, dito rin nakalagay ang table for 2001 NSCP code and 2010 or 2015 NSCP code. So, this is for economical design. So for us to see if this program works really well, let's have an example. So here I have prepared a sample. So the problem states that the designed economical spacing of 10 millimeter diameter stirrup for the beam which carries the factored loads shown. So use DFC prime of 21 MPa and FY of 276 MPa. So, dito makikita natin sa figure na ang beam natin ay ang length ng beam natin ay 6 meters. We have a point load at the center of 150 kilonewton, dead load of 40 kilonewton per meter, live load of 20 kilonewton per meter. And given na dito yung reaction, but still we will solve that because magkaiba yung reaction ng 2001 and 2010 or 2015. So in the cross-sectional section, we have 30 millimeter width of the beam. We have an effective depth of 536 millimeter. So that's all the given that we have. So let's input those value. So we have a dead load of 40, live load of 20, point load of 150, beam length 6 meters, beam width 300 mm, effective depth 536 mm, diameter of the stirrup we have 10, number of legs 2 lang. Kikita natin dito na enclosed na siya sa isang box or isang beses na siya nag-loop. So kaya 2 legs lang. If dalawang loop or tatlo, matatawag natin siya na 3-legged or 4-legged and so on. So we have FC prime of 21 and FY prime of 276. Tama ba? 276. So that's all. And see in the calculation sa M1 or yung slope ng ating shear, we have 90. Sa M2 in the 2010, we have 80 slope. So sa 2001, we have sa 2001, makikita natin na uniform load niya is 90. Magkapareha lang sila sa slope halos, 'di ba? Tapos yung uniform load in 2010 or 2015 is 80. And so mamaya na yung X max 1 and 2. So let's go here in the reactions. or the values that are computed in 2001 NSCP code. The reaction is 345. By the way, this shearing beams program only supports simply supported beams. So let's continue. So we have ultimate shear of 296.76, shear in critical section of 122.81, and VS of 226.32 kilonewton. So in 2010 and 2015, we have a reaction of 315 kilonewton, ultimate shear of 272.12, shear in critical section of 125.87, and VS of 237.56. And so, here, makikita natin na may condition siya. So, VU is greater than VC. So, we must design a stirrup. Also, it's the same within the 2010 NSCP code. So, we will proceed in getting the spacing of the stirrup. So, we have VC over 2 of 61.407, 2 VC of 245.63, 4 VC of 491.25, and so the area of the section is 157, the same lang sila sa NSCP 2010 and 2001. Now, sa S ng 2001 is 102.63, while sa 2010 is 97.77. And so, we will assume a rundown value of our spacing, so that in order to be safe, so let's say we have 100 here in 2001 and 90 in 2010 and 2015. So now let's check for the adequacy. So here the VS is 486.34, which is greater than our VS computed here in the above. Same in the 2010 and 2015 NSCP code. So it's okay. Next is checking for the S-max, and so we have a condition here. If the VC over 2 is less than the VS, and VS is less than 2 VC, so here we can check the condition for S-max. So makikita natin sa number 2 siya nakalagay. So ibig sabihin dapat yung S-max natin dito is number 2 rin. So if 2 yan siya dyan, this will be the given range of your S-max. And dito sa 1, 2, 3 na to, kukunin niya yung pinakamaliit na value, which is yung number 3 or yung value nung S mo, which is 102.63 sa 2001 and 97.77 sa 2010 and 2015. So let's say value again for our S-max, which is 100, and for our S-max in 2010, 90. So that's it. And then it says here that AV mean required. So we will set a value of our AV mean required. And so the value of our AV mean is 30.88, which is smaller than our AV value, which is okay. Same here in 2010 or 2015 NSCP code. Okay, now let's go for the location of our first stirrup. So here in 2001 NSCP code, we have a value of 25 mm. So let's say just 25 mm. And here in the 2010 or 2015, we have 22.5, which we can say 20. And so we can go here for our economical design for the number of spacing in each section. So first section, which is the less than 536 for our D or effective depth. Now the S is 102.62, which is greater than S max, so we must follow our S max in 2001, which is 100. And also here, and lastly here, 100. So it only means that if the value of your S will be greater than your S max, So you must use your S max all throughout the length of the beam. So here we can see the number of stirrup in this section. So which is 5. Let's say 5. And here, let's say 5. And then, let's say here, about 10. Cerrado. And in 2010 and 2015, the spacing is greater than S max again, which is not good. So let's use the RS max for all values, which only indicates again that the S max or the spacing will be used all throughout the span of your beam. So here we have value of 6, 5, let's say 5, and let's say 11. And so we can design our beam using this spacing and the number of stirrups in that span. And that's all, I think. Thank you for watching.